I am Donghyun Park and I'm a testing specialist for LG CNS in South Korea. It's such an honor to meet you all. Presenting in English is new to me and I hope you can all understand me clearly. Today, my presentation is about a viable way to overcome performance problems right after system rollouts. I hope this will help save time and make things easier. After my presentation, we will have some time for questions and answers. Does this picture remind you of yourself after a long day at work? In my country, this is very common. Korean people are relatively short-tempered and like things to be done quickly. In Korea, you can often hear pali-pali, which is Korean for quick. I think this quick culture has helped to boost the IT level of Korea. Many IT engineers and experts work day and night, weekdays and weekends, with their bosses standing over their shoulders saying pali-pali. So they are forced to be tired like this picture. How about you? I hope this presentation will help these weird people through lower performance problems and lighten the workload. First, let me introduce you my company and our roles. Then I'll explain the main subjects of my presentation. I think everyone here knows about LG. In this hotel, my room has a TV made by LG Electronics. LG has three main business areas, and among them, LG CNS belongs to the area of communication and services. And our annual revenue is over 3.5 billion. As it is well known, in the UN e-government survey, Korea has been #1 for consecutive 4 years. 60% of Korea e-government projects have been successfully implemented and maintained by LG CNS. This reflects that LG CNS has offered high quality and advanced services to its customers. In the government services area, LG CNS has many e-government solutions like G4C and KICS. G4C stands for Government for Citizens and KICS stands for Korea Information System of Criminal Justice Services. In the citizen services area, Seoul City's transportation system project is the most representative project. And the government integrated data center project was also a major project in the security services area. Now our roles. My team members and I have participated in most of the public IT projects. We are offering various technical and quality services to those projects, including technical problem solving, performance testing and tuning, system rollout support, system process, diagnostics, and emergency response. And now I'd like to share the know-how based on the experiences of performance testing and tuning over 10 years in those public projects. In most of system integration projects, performance tests are usually done before the system rollouts. But there are cases that serious performance problems occur right after the system rollout, even though performance tests show the system's performance goals are met. Why does this happen? Typically, we carry out software development projects in the order from initiation and planning, analysis to test, go live, and roll out. The test phase is usually composed of unit test, integration test, system test, user acceptance test, and during the system test, performance test is executed. Performance testing is executed in 5 steps from planning to evaluation. In the analysis step, workload estimation is the main task. In the design step, we decide how much volume of test data is required and create test cases and scenarios. In each step, doing every task right is very important to make sure the system's performance. Any unintended faults such as inaccurate workload estimation, unreasonable test cases, or careless system modification after testing can cause performance problems. Let's look at the real user environment. End users work on the computer from many different remote locations. That is, they are connected to the server system via WANs, which has some level of network latencies. On the other hand, in the test environment, a limited number of users are connected to the server system via LAN. As you know, LAN has much less network latency than WAN. In performance testing, lower number of virtual users are used instead of real users as clients. And the virtual users are connected to the server system via LAN, not WAN. So using virtual users and not considering the differences between LAN and WAN may cause potential performance problems. To wrap it up, the causes of performance problems can be divided in 3 main categories. First, from the server side, there can be inaccurate workload estimation, unreasonable test cases, or insufficient test data volumes. From the client side, there can be too many round trips between the user and web server. Lastly, from the management side, there can be a loose modification management after testing. Now, let's take a closer look at the main reasons which cause performance problems right after system rollouts. We will also propose practical solutions to minimize or prevent these performance problems with some real cases. Once we set up overall test scope and schedule in the planning phase, we should estimate the possible peak workloads to the system under test. These estimated workloads are used to determine the throughput goal, which is the most important one of the system's KPIs, and refers to the largest number of transactions which can be successfully performed by a system per second. Once the system is set up, the workload must be calculated based on the highest peak load in order to preserve the normal operation service in any workload situation. If we estimate the peak load bigger than the real load, it could exceed the system's capacity, and performance tests will always result in a failure without capacity increase. On the contrary, if we estimate the peak load smaller than the real load, it could lead to misleading results. Even if the performance test shows the system can handle the estimated peak load reliably, it can lead to potentially dangerous situations since real peak load is much bigger than the estimated one. So workload estimation should be done appropriately because it is the starting point of the performance test and forms the basis of the performance goals. There are a few methods of workload estimation. One is based on transaction information like system log, and the other is based on the number of users. In case of the renewal of legacy system or next generation system development projects, we can have existing usage information by users, such as access logs, database transaction logs, and so on. Let's see how the workload is calculated by log analysis. We can find out when is the peak hour of the year by analyzing access logs in the order of peak month, peak day, peak hour. Then we can estimate the target workloads by converting the number of page views of the peak hour into TPS and applying corrections according to workload characteristics or customer requirements. If we can find out the number of transactions per hour from the database as shown here in the number of transactions of emitted electronic text receipts, then this estimation method is applicable. In case a new system, solution, or architecture is introduced, we should take into account changed characteristics of transactions in addition to analyzing existing systems logs. The new system, solution, or architecture can have different transaction characteristics in terms of volumes, intervals, and so on. If we have a new window screen which calls 5 existing transaction services at a time, the workload for the new window screen should be 1/5 of the existing workloads. Therefore, we have to find out how many existing transaction services called in each and every window under test and apply the results to final workload estimation. In case there is no transaction information or existing system, workloads can be estimated through the number of concurrent users. The most frequently used and well-known formula is Litter's law. When generating the laws with performance test tools, we use virtual users, also called active users. First, let's find out the definition of concurrent user and active user. A concurrent user is someone who really uses a system resource. That is, a user who inputs transaction data, reads the search results, or waits for the system responses. An active user is someone who just entered and waits for the transaction responses. That is, a user who creates processing requests continuously in the system. The relations between both users can be shown in the right diagram. We can derive TPS from the formulas in the left diagram. Although not as accurate as log analysis, if the number of concurrent users and request intervals during peak time can be estimated reasonably, it's considered as a good method. If the peak time number of concurrent users is difficult to be estimated, we can apply peak time corrections to the average number of concurrent users. Regarding the think time, we can refer to the measurements table in the right side. If the previous methods are not applicable, persons in charge who understand the system best should estimate the transaction volumes. This can be the most inaccurate method. In this case, we can estimate workloads by using this template. First, list all our main programs in the leftmost column. Then write down the number of users for each application program. Lastly, write down the number of transactions by one user, both during peak hour and during working hours. Finally, we can calculate the peak time number of transactions and the number of daily transactions multiplying the number of users by the number of transactions by one user. Now we can convert the peak time number of transactions into peak time TPS and convert the number of daily transactions into normal TPS. Estimation by log analysis based on access logs, database transaction logs, and so on is accurate in general and hardly causes problems. When determining the throughput goal, we usually add 10 to 30% to the estimated workloads as a correction. However, in case of using Litter's law or template analysis, estimation accuracy greatly depends on the tester's level of experiences and the knowledge of the system under test. So estimations by Litter's law or template analysis are relatively inaccurate compared to the estimations by log analysis. In that case, we can be sure there will be no performance problems even during peak time after system rollout if any problems were not found in the performance test based on these estimations. We can't be definitely certain because those estimations include inevitable errors. So we can prepare additional test cases as safeguards against possible problems. A few multiples are applied to these test cases like 2 times, 3 times, and 4 times the target workloads. In this way, we can confirm how much load the system can handle reliably and know the performance limit of the system. This would be very useful and helpful in operating and maintaining the system. Since tests against all application programs are not efficient in terms of time and costs, performance test cases usually cover some part of the applications, which are selected in a sampling way. For better efficiency, applications for tests are selected using Pareto's law. It means that 20% of application programs cover 80% of application transactions. But since only 20% of applications, not all the applications are tested, it should be done carefully to select the applications for test. In addition, end users' usage patterns of the system should be reflected in test cases. In other words, every test case should be as realistic as possible. For example, in the case of file handling applications, files used for performance tests should be used with a realistic and reasonable size, since the performance of those applications greatly depends on the file sizes. This is the case that only applications thought to be bad performers were tested and consequently caused a problem after system rollout. They missed critical and most frequently used applications. So the performance test did not reflect real situations after rollout. It's likely that developers ask for testing the applications which seem not to be good in terms of performance. Testers should try to avoid this situation through appropriate interviews with developers. On the other hand, it's rare, but in some cases, developers try to keep their applications from testing due to the fear of exposing the bugs of their applications. Testers should also check that this situation does not happen. Generally, it's not necessary to include the online applications which are not frequently used during weekday working hours in the test cases. If batch applications run at night, when the system has little load are completed within the predetermined time, they would not matter. And for the long-running online applications which are not frequently used, they need separate performance tuning aside from the performance test. This case shows response time variations of a financial system which processes slips or receipts through MS Excel files according to the file sizes. The financial system does not process each slip or receipt, but uploads all the slips or receipts for the certain period of time in the form of Excel sheet records and process them at one time. Of course, the Excel file size and processing time depends on the number of records. Persons in charge said that 1 megabyte would be the largest file size, but some 11 megabyte files were also used in the performance test. After rollout, the system actually processed 7 to 8 megabyte files frequently. In selecting the applications for test, we can use some criteria like number of users, frequency of use, concentration level of use, complexity, and importance priority. By giving a score to every application for each criterion, multiplying the weight of each criterion and obtaining the final score, the applications with more than a certain score will be selected for test. Besides these, in case there are additional applications requested for test by customers, they may also be included in the test cases. In order to give a score to each application for the 5 criteria, you can refer to the guidelines in the scoring criteria. Scores will be relatively given to each application from 1 to 5. This relative score will vary from system to system. It must be kept in mind that the most important thing in doing this task is to discuss with experts who understand the system well and to have a consensus with customers. There exists one consideration here. As mentioned before, it's not efficient to test all the applications in the performance test. Then how about the applications which were not chosen to be tested? What should we do if these applications have inherent performance issues? Our suggestion to eliminate this kind of worry is to install and configure an APM solution on the development or test server and check the response time of each application at the stage of unit test, integration test, or user acceptance test. If any application turns out to have more than predefined response time goal or excessive system resource consumption, it needs continuous tuning until it meets the goal. Through these activities, we can have a similar effect on performance testing against all the applications. This is very helpful for solving performance problems in advance. And we have to prepare test files with the same size as real situations for testing file handling system like a document management system. If it's not possible, we need to prepare different files with various sizes like average size, minimum size, maximum size, and so on. Also, we need to make several test cases with different file sizes. Like this, sufficient test cases in one test scenario would significantly cut down on the uncertainties in performance. After workload modeling has been accomplished at the analysis phase, in the next phase, design phase, we have to prepare data for test. This is a typically difficult and time-consuming job. In the case of system renewal or building a next-generation system, we can secure sufficient data with relative ease through data migration from the legacy system to a new one. But if we build a whole new system, in many cases, there is not much data in the database system. In this situation, the performance test has no meaning because response times of most applications will be absolutely fast. It's rare for the migration of the legacy system data into new system if there is no such case in the new configuration system since there is no data. Under this condition, there is no reason to run the performance test since the inquiry performance is definitely good as there is no data. This is not an error case after the rollout, but it shows differences in response time according to the amount of data stored in the database. It's the test results for all lab systems of a few education offices, DW systems, and each office has different data volumes depending upon the number of schools and students. The execution time of SQL can vary hugely depending on the data volumes accessed, tuning applied, and join methods. For example, a SQL query can be completed by accessing only indexes, not tables. Even accessing tables, data amounts accessed can be greatly reduced using indexes. But in this case, under the condition that every SQL query is tuned completely and cost-based optimizer is used, we could find out that the difference in response time was caused mainly by the amount of data. Each query returned different rows accessed and fetched from the database and had different response time accordingly. This table shows the results of executing a SQL query for 2 user tables with 1 month and 1 year data stored respectively. The execution times of a SQL query for a table with millions of data records and the same table with billions of data records definitely differ, although it's not necessarily proportional to the amount of data. I recommend you prepare at least 1 year's volume of data for the performance test. And we have to bear in mind a few things when it comes to creating test data. First, total volume of test data should be adequate. 1 month and 1 year volume of data has a big difference in performance. Second, test data should ensure reasonable cardinality. That is, any SQL query should have a appropriate number of data records in its result set, and if in real situations, the system has evenly distributed data across the year, test data should also be created with an even distribution across the year. Now, how to create test data? Since manual creation of test data is nearly impossible, automatic creation is usually utilized using various methods. Generally, there are 3 ways of creating test data. First, data migration. Second, data creation program development using procedure, SQL, Excel macro, or something, and utilizing performance test tools. Data migration is a relatively easy way because we can make use of legacy data. Data creation program development requires understanding of data types, attributes, and related business rules. So it needs active cooperation of developers. Performance test tools can also be utilized in case data creation is possible through the already developed applications. For example, if any workflow or data input pages are provided like ERP or BPM, a certain volume of data can be created automatically using performance test tools. At the execution phase, based on the results of previous activities, we perform actual testing by generating workloads to the system. The most realistic way of performance testing is not by using a testing tool, but with the real users using the system. This is the most perfect way of repeating the expected real situations after the system rollout. But in reality, it's expensive and certainly not easy to gather and control all the people who should participate in the performance test. For this reason, workload generation is done by virtual users, not by real users, which are commonly implemented as threads in performance test tools. At this time, it can be an important decision which concept of users to be used. In most web-based application systems, it does not matter whether active users or concurrent users are used, because the most important performance KPI of OLTP system is the capability of processing how many business transactions at the same time. The number of different users who access the system is not so critical. If this is the case, We can use active users which have little think time or pacing time as virtual users. This can also reduce licensing fees charged by the testing tool vendor for the number of virtual users. But things can be different when it comes to ERP or client-server system. For Oracle ERP, whenever a user uses a new form screen, the application server forks a FRM web process which consumes about 40 to 50 megabytes of memory. Thus, if active users are used, we cannot check for the necessary memory usage, although we can still check transaction processing throughput. Although almost all performance tests against typical web-based application systems have been accurate with active users for several years, we need to refer to these cases. This system met the performance goals in the performance test, but the application servers encountered performance problems after the system rollout. This was because the application servers suffered from lack of hidden memory due to huge concurrent number of logins of real users. Even though Oracle ERP meets the performance goals with active users, and there is no lack of system resources, the application server can have lack of memory and cause significant service failures as the number of users grow. Since the application server forks on new processes for each formed screen and it consumes considerable memory as mentioned before, it's important to estimate how many users will access the system concurrently in the system environment like Oracle ERP. In most cases of web-based application systems, we can carry out performance tests against the system with active users calculated based on workload models and leaders' role. But if the system which requires a large memory allocation per user session like ERP and SSO, it's highly recommended using connected or concurrent users as virtual users and measure the amount of free memory while also considering future growth of the users. Performance test tools like Load Runner have some limitations on measuring and analyzing system performance on the client side. Since the response time of typical web-based application system is composed of end-user processing time, network time between end user and web server, network time between servers, web server processing time, WAS processing time, and DB server processing time, end user processing time and network time should be analyzed as well as server processing time. Even if server performance has been optimized, if end users feel the system is slow, they will complain about the system performance. This is the reason why the client-side analysis of network time is required. An end user at a remote site complained about the response time, and we performed an analysis to identify the root cause. The analysis showed that for some web pages, there were too many network round trip between the end user and web servers, and this degraded the end user response time. So for the problematic web pages which have over 100 URIs, we merged the 20 to 30 JavaScript files into 1 to 2 files and removed the unnecessary duplicate URIs. This improved the end-user response time significantly. In addition to these, we set data compression options on the web server software, and this reduced network traffic dramatically. Client-side reliability and performance are as important as those of server-side after the system rollout. Client-side performance analysis and verification could be done in the performance test utilizing useful tools such as Fiddler, HTTP Analyzer, Wireshark, and so on. After the system has been tested and optimized for its functionality, configuration, and performance, it's not desirable to change the functions or configuration of the system. However, if any change is really required, the system should be run through a performance test again after each change. A web firewall option changed right before the system rollout, which caused quite slow connections to main pages. A web firewall inspects all of the network packets passing through it to detect harmful packets like external attacks, and has 3 configuration options such as detection only, block after detection, and bypass. In this case, a change had been made from bypass to detection only after the performance test. This increased the load to the web firewall and caused significant service delay as a result. For public service systems with heavy traffic, added care is required when setting or modifying a configuration option. If any changes are required, such as a modification of application code, addition of business applications, modification of configuration parameters, and so on, we should analyze these changes and determine whether these changes will have an impact on the whole system or on a few specific modules. If necessary, another performance test should be done. In many projects, I have experienced that changes initially regarded as trivial caused unexpected failures later. Any slight change could possibly have huge effects on the system. If the change's effects could be reviewed by independent expert groups, that review will help to minimize the risks. Because most performance issues cannot be found until the system loads go over a certain level, it's the safer to do another performance test. We know that taking precautions can save much more money rather than taking countermeasures from our experience, as well as the performance issues may due to brand image or customer confidence. Through modeling future workloads and simulating real situations, performance testing can proactively eliminate or minimize performance risks without having to undergo any problems once the system is rolled out. With the real cases of performance tests, we have looked at several key reasons which make the differences between the performance test results and the real situation after the rollout. We have reviewed the improvement methods that are necessary to overcome the performance issues in various situations. Please look at this table for the key reasons and improvement methods. If applying these performance testing best practices and the improvement process, the simulation will be as close to the real situation as possible, and almost all the performance problems will be found and solved before the system rollout. That is, we can expect a successful system rollout. Before we start the Q&A period, I would like to apologize if I have a bit of a hard time to answer your questions. My English listening and speaking isn't fluent yet, but my writing and reading is good. If I can't answer your question to your satisfaction, feel free to send me a written email to these addresses and I will get back to you in greater details. Does anyone have any questions for me? Thank you for your attention.